Okay guys, today we're going to look at similar polygons. And in the warm-up, I'm not really going to worry about 3 and 4. We've done enough of work with the proportions that I don't feel like that's really a big thing. But I am going to look at 1 and 2 here, where we've got a quadrilateral that's got 2 parallel lines here. The defilitator parallel don't really say what's going on with these two, but we're going to look at this quadrilateral almost like we looked at a transversal going through 2 parallel lines, okay? And if you had that, you would look at these 2 angles, U and X, as consecutive interior angles. We know consecutive interior angles are going to be supplementary, meaning they have to add up to 180 degrees. So all we're going to do to find a measure of U is just take 58 away from 180. And we're going to get 122 degrees for our measure of angle U, okay? Now we're going to do the same thing with V and W. V and W are consecutive interior angles, okay? So we're just going to take 61 away from 180. Okay, so you've got 180 minus 61, and that's going to equal 119 degrees. So our measure of angle W is going to be 119 degrees, okay? All right, moving forward here, when we're talking about similar polygons, the corresponding angles are going to be congruent. Find my eraser here. I'll use my hand until I find that. Our corresponding angles are going to be congruent. So if you look at polygon A, B, C, D, that's going to be similar to E, F, G, H. Very important that you line everything up properly here when we're talking about similarity. Notice A and E are going to be the first ones here when we line them up, okay? B and F are the second ones, C and G are the third ones, and so on. Everything lines up, okay? And we're talking about similar polygons. Now, the angles here are going to be congruent, but your sides are going to be in proportion. AB, the proportion ratios of AB over EF are going to equal BC over FG, and we'll work it all the way around. So let's line this up. Okay, we know that AB EF is going to equal BC over FG. And that's going to equal CD over GH. And that's going to end up being equal, you're going to have DA over HE. Okay, so they'll all be in proportion. I think this is something where I'm explaining it to you right now, but it's a lot easier to see, I think, when you see it through an example, which we're going to do next. And I'm just going to check to make sure we're lined up right here, so we look good. Okay. Found my eraser here. Okay, we're going to look now at our first example. Okay, they're telling you that JK LMN is going to be similar. It's going to be similar to ST U V W. Okay, they're going to be similar. Meaning our angles are going to be congruent here, okay? So we know that angle J and angle S are going to be congruent. K, we just keep adding another arc. We go to the second one, third one, 3 arcs. Okay, L is going to be congruent to angle U. Okay, angle N is going to be congruent to angle V. And finally, angle N is congruent to angle W. Okay. Okay, so they're all the angles that are going to be congruent to each other. And again, we know that if we want to line up proportions, we're going to see that JK over ST, or line up different ratios, probably a better way to say that, JK over ST is going to equal, KL, okay, over TU. Then we're going to have Ln over UV. Okay, we've got Ln over UV right here to here. Then you're going to have Mn over VW. And then finally you're going to have NJ over WS. NJ over WS. Okay, so this is again how we're going to line everything up. And again, they're telling you that this is similar, this is how things are going to line up. This is kind of a little bit like the previous example, but you're going to, again, you're going to see really once we deal with numbers, how things are going to all come together, especially with your ratios right here. Okay. We're going to move to example 2. And here's where I think we're really going to see everything come together. They want you to show whether the two figures are going to be similar. Okay. One thing they tell you is that your angles, when you're looking at W, X, Y, and Z, your angles here are going to be congruent, okay? You've got the angles congruent, so you're good there, okay? So, if you want to try to prove that W, X, Y, and Z is similar to PQRS. Figure PQRS. Okay? It may or may not be similar. Okay? We're going to see. Well, we know we're good with the angles. Okay? Angle W, we already said that. Angle W is congruent to angle P. Okay, and angle X is going to be congruent to angle Q. Angle Y is going to be congruent to angle R. And angle Z is going to be congruent to angle S. Okay, so we know all the angles are congruent. We're good there. Next thing we have to see is if the sides are all in proportion, okay, all share the same ratio, okay. So we're going to look at WX, okay, over PQ. PQ, okay. WX is going to be 15, okay. PQ is going to be 10. I'm going to line this up, and I think I'm going to come back and kind of put everything together here. All right. We look at XY over QR, and XY over QR is going to be 6 over 4. Okay, different initial numbers, but you'll see we reduce. That's going to really tell us if everything's in proportion. Okay. Then you're going to have YZ, okay, YZ over RS. And that's going to give us a 9 over 6. And then finally, you're going to have ZW over SP. Okay, ZW over SP, you're going to get 12 over 8. Okay, obviously they're all different numbers, but if you think about a proportion, it has to reduce down to give you the same ratio. Okay, and we look at this, 15 over 10 reduces down to 3 over 2. Okay. 6 over 4 reduces down to 3 over 2. So far we're good. We've got the same ratio. Okay. YZ, 9 over 6 reduces down to 3 over 2. And then finally, 12 over 8, 4 goes into 12 3 times, goes to 8 2 times, reduces down to 3 over 2. So we're good. We've got all congruent angles, and we've got all of the sides, okay, are in proportion. Okay. So because of that, we know that we've proven that WX, YZ is similar to PQRS. Okay, we prove that. Okay. So that is example number 2. We're going to work our way down here to looking at a couple things with the scale factor. Okay, and the scale factor is just going to be, and I'm going to leave part of this up here. Scale factor, the ratio of the lengths of the two corresponding sides of the two polygons. Okay, so we have corresponding sides here. Okay, corresponding sides. They're all in proportion, and they're in a scale factor of, for the lengths of the two sides, of 3 to 2 when we're talking about WXY to PQRX. Okay, this one's going to be in ratio of 3 to 2. Okay. And the scale factor, again, we're going to rewrite, it's almost asking the same question. Of polygon WXYZ to polygon PQRS is going to be 3 to 2. Okay? Remember, we can write this as with a colon, or we could write it as a fraction. It means the same thing. Okay, now if we do it from polygon PQRS to WXYZ, we just reverse this. This is going to be 2 to 3, or 2 over 3. Okay, so that's what we're talking about when we're talking about scale factor. Okay, here's a theorem. If the ratio of two polygons, if two polygons are similar, then the ratio of the perimeters is equal to the ratios of the corresponding side lengths. Okay, let's see what that means. And I'm just going to basically give you a rectangle. And we'll use what we have used here. Okay, 3 and 2. Okay, with a rectangle, obviously, you know the opposite sides. Are going to be the same. And if we had another rectangle, it looked like this. And this was 4. And this was 6. Okay. Obviously, this is 6. This is 4. Okay. These two rectangles are going to be similar. All right. And the scale factor for these two rectangles are going to be 1 to 2. When we reduce 3 over 6 reduces down to 1 to 2. 2 over 4 reduces down to 1 to 2. Okay. What they're saying is that the ratio of their perimeters will also equal 1 to 2. Well, let's look at their perimeters. Okay. If we had 3 and 2, 5, okay, 3 and 2, 5, you're going to get 10. Perimeter equals 10. And the perimeter here equals 20. Okay, so we're going to end up having the two figures have a scale factor of 1 to 2. When you look at each side, 1 to 2. When we reduce them, okay, I'll even do it over here. 3 over 6 reduces down to 1 over 2. 2 over 4 reduces down to 1 over 2. Okay? This theorem says that their perimeters are also going to reduce down to 1 to 2. And they, sure enough, they do. 10 over 20 equals 1 over 2. So that's basically what this theorem is going to say. Okay? Okay, this is going to be similar to some of the problems that you're going to see. Okay, JKLM is similar to quadrilateral PQRS. All right, you want to find the value of Z. So we know that PQ. Okay, you can even again these are all turned around. So PQ is going to be the corresponding side with PQ is going to be JK. Okay, so PQ Z is going to have a corresponding side of JK, which is 10. Okay, because PQ lines up with JK. Okay, PQ first and second, JK first and second. All right. Then we're going to have KL, okay, KL is going to line up with QR, okay, so we want to make sure we go from this figure to this figure. So it's going to be QR 6, okay, QR over KL 6 over 15. And then we would just use cross multiplication to finish that off. All right. And you would end up getting 15Z, 15 times Z equals 6 times 10 or 60. Divide through by 15, Z equals 4. Okay, we're going to get 4 for Z. Okay, and that's it. Okay, and again, with this one, I'll even go look at this one again. Remember, we had PQ, okay, is going to be lined up with JK, okay? Or if you wanted to do it, you could say JK to PQ. You could go big to small. All right, you could do that either way. All right, we found PQ here, that was our Z. We went small to big, Okay. And we're going to end up getting 4 for our answer. Okay. I'll even do this going big to small. Okay, let's show this a second way. If we did JK is going to be over PQ. Because they're corresponding sides. Okay. JK over PQ is going to equal, and we have to go with what we have, values that we have here. KL over QR. Okay? Equals KL over QR. So here we went small figure to big. Here we're going to go big to small. JK is going to be 10 over PQ. That's just going to be Z. That's your unknown. Okay. And then KL is going to be 15. And then QR is going to be 6. We do our 15 times Z equals 10 times 6. 15Z equals 60. Divide by 15, divide by 15, and Z, again, still going to equal 4. Okay, so instead of going small to big, I went big to small. Key here is just lining everything up properly. Okay, and that's it. Okay, 8.3 is finished. That was similar polygons. All right. Any questions? Like I said, email me, and I'll probably put some examples done, like the first example finished on the worksheet. And I will see you tomorrow for 8.4.